All right, looking at number 24 here in section 11.1. We're looking at a sequence. If we have a sequence whose algebraic rule of correspondence says an is n plus -1 to the nth power divided by n, then we can say that the limit as n goes to infinity of a sub n is the limit as n goes to infinity. Oh no, I'm do that sometimes. Write one thing on top of another, I accidentally write that stinking line there. I don't want to do that. Don't have any white out though, and I'm using a pretty dark pen. Oh well. Pretend I didn't do that. Okay. That would be n plus -1 to the n, the algebraic expression. Okay, so I can write this as the limit as n goes to infinity of 1 over n in the numerator and 1 over n in the denominator with my n plus -1 to the n. And similarly, the n down here. Okay. That, I'll say, is equal to the limit as n goes to infinity 1 plus -1 to the nth power over 1. Okay, so I guess I don't have to do anything with an n. Okay. And that is 1 plus the limit as n goes to infinity -1 to the nth power over n, which, okay, so that should just be 1. I think that -1's not going to get any bigger as it alternates sign, and then the denominator will get bigger and bigger. Okay, so now that I have an idea of where this is going, let's actually make sure that I can construct a proof based on the definition of convergence of a limit. I'll argue, since if epsilon is some number greater than 0, then the difference n and 1, okay, so the absolute value of the difference between a and 1, by the way, that is the absolute value of n plus -1 to the nth power over n minus 1 here. Okay, I can rewrite this. Oh, look, I'll modify the first guy over here, n over n, that is 1 plus -1 to the n over n. Okay, so then I'll subtract 1. Oh, look, okay, 1 here, -1 there. That is the absolute value of -1 to the n over n. Oh, but with the absolute value, look, if I get a minus sign, then I can just replace it with a plus sign. If I have a plus sign, then I just leave it as is. So this is 1 over n. Okay, so the idea, now that I've simplified an minus 1 quite a bit, is that I can force this to be less than epsilon by saying that it's less than epsilon if n is sufficiently large, in particular if n is bigger than 1 over epsilon. Just for an example, if epsilon is 10 to the -100, okay, so that's a googolith, then an minus 1 is less than epsilon when n is bigger than 1 over epsilon, which is 1 over 10 to the -100th, which is simply 10 to the 100th. That is to say, when n is bigger than a googol, an minus 1 is smaller than a googolith. Oh, pardon me.